get started. I am going to go over 5 assignments for you and tell you what the expectations are, and then show you some new examples that I just uploaded as well. So this is intended for you guys to figure out what exactly is due. The first one has been posted for a very long time, actually, so let me just refresh your memory on that one. It has not changed. It's the same assignment. These are also uploaded into the EMS as well, so you can download them and start doing them. And this is only on the 3rd week of class, but feels like it's been longer, doesn't it? Anyway, long story short, the assignments will be due at the end of August sometime. Actually, I have the date. They are due. Let me show you the date. All of the assignments will be due the same day as the final exam, which is going to be on August 27th. So you have, what is today's date? The 20-something, 23rd. So you have like a month, 4 or 5 weeks. So, which is plenty of time, I hope, for you to do it. Assignment number 1. Have I gone over assignment number 1? Or did I just say it was up there? Wait, this is wrong. This isn't. This is the wrong one. This is a lecture. Oh, I like that though. Let's see. Here's assignment number 1. Let's see. Preview. Let's open it with preview. Okay, assignment number 1 is in 2 parts, and you're supposed to do both parts. And the way this works, let me make this a little bit bigger. There we go. I think I went over this one last time, actually. So just in case you missed it, it's done in 2 parts, and you do both parts. Actually, all of the assignments are in multiple parts, and as we'll see, all the parts work together, so you only have to really write one driver program, and all the classes work with it. So in this particular assignment, you are to complete both parts, and you have conditional logic where you're going to use the equals operator and the ands and the ors and stuff, and then you're going to write some methods and some parameters. A simple class implementation is what this is about. And this is where I showed you the link, actually, for the appledeveloper.com website, where you can go on and take a look at COCA and the documentation. And I believe I actually covered assignment number 1 already, which I posted up this weekend was assignment number 2, 3, 4, and 5, the rest of them. So those are the ones I really want to go over and preview for you. And this one is assignment number 2. Let me make it a little bit bigger. That was a lot bigger. Hold on, let me make the screen bigger now to accommodate for the bigger file. Alright, so in this particular assignment, it's again complete all parts, and there's 3 parts to this one. Don't let the number of parts fool you, it's not that complicated. So in this particular assignment, part number 1, we're creating a date class, and in the date class, it's assumed, I probably should have put it on here, but it's assumed you have a .h and a .m file for each one of the classes that you're creating. So you have a total, if you're creating a payroll class, a date class, a day of the year class, you've got 1, 2, 3 classes, 1, 2, 3 classes, 6 files total, plus a driver program. Yeah, a driver program doesn't require .h, a driver program can just be a .m file. So what are we doing here? We're creating a date class that represents the concept of a date. We don't actually have a date object, hello, that we can put in here, but what we've got down here, I mean, built into as a data type, and so we're creating an object for it. The class is going to store the date in 3 different integers. Simple integers is fine, month, day, and year. You'll also be a member function to print the date. You may use any type of initializer as you want. I know I talked about initializers last time. I talked about the property and synthesize. I have some examples to show you today, which you're really going to love, because they're going to show you how to create the classes. I didn't do a date class or a payroll class. However, you can easily follow through this system. In fact, you could probably do all of the assignments in one night after seeing these examples. Yeah, there's no excuses why anybody in this class has to cheat. The assignments are not even a challenge. The assignments are so low level that I purposely made them easy to discourage you from cheating. Anyone who is caught cheating this particular term will be brought up on academic dishonesty charges, as well as receiving 0 for the assignment. So last term it was 0 for the assignment, but no formal write-up. This time the assignments are so easy, it's impossible for you not to do them yourself. If you can't do these assignments, you really don't deserve to pass the course. this is how easy these assignments are. All right, so they're all on inheritance, and they're all on creating classes, which, you know, if you think about it, that's what you're in here for, to figure out how to create classes and how to extend classes from other classes, you know, inherit and how to write stuff. But anyway, they're not hard. And as long as you do it yourself, even if it's not functioning correctly or to as best of your abilities, it's still worth credit. And you're not going to get 0 on it. If you give me somebody else's recycled assignment from, in fact, these are impossible to recycle, which is another good thing. Instead, one student's going to write them and then send out the answers. The person who originally wrote it is going to get 0 credit as well, however. Everybody will get 0 credit. If your assignment matches at least one other student in the course, the assignment's not worth any credit. So everything has to be original. And I mean that, actually, because of the accreditation and things, you know, we have to actually start enforcing these rules. Not my decision, it's the university's policy. Anyway, long story short, now that I've scared the life out of you, now you're all thinking, I have to write these things. Yeah, pay attention. You actually have to write these assignments if you want to pass this course. All right, so, all right, what do we got going on here? You're going to create a date class. The date class is going to have a function to print the date. It's going to have a function to print the date in these 3 different formats. One using 12/25, that looks like Christmas Day, 2012. Or December 25th this way, or December 25th that way. So perform the following input validation on the on the second assignment. There's a lot of input validation on it. So this is the interesting part here. A lot of the other assignments don't have input validation. So do not accept values of a day greater than 31 or less than 1. You know, what day is 0? What day is that, you know? Do not accept values for the month larger than 12 or 1. So do some error checking on the input. I'm going to show you actually how to look at numbers today as well and convert strings to numbers, which you're going to need to do actually for this. Because if the person enters in a string, you know, it's going to have to be converted to a number. You know, if you're going to do date calculations and stuff. It doesn't have to. You can compare it. You don't have to do any conversion at all if you don't want to. But all right. So the first part is to create this date class. The second is to create this payroll class. So you're designing a payroll class that has data members for the employee's hourly pay, rate, number of hours worked, total pay per the week. Then you write a program with an array of 7. An array of 7 payroll objects. So can you put an object inside of an array, which is not too difficult. Program should ask the user for the number of hours each employee has worked, and then should display the amount of the gross pay that each has earned. Okay. Perform some input validation. Do not accept values greater than 60 for the number of hours worked. So you can't work more than 60 hours a week, essentially, which is 40 is full-time in America, so 60 is like way. All right, so that was number 2. Part number 3 is the day of the year class. Assuming that we have 365 days in a year, write a class named day of the year that takes an integer representing the day of the year and translates it to a string consisting of the day followed by the month followed by the day of the month. For example, day 2, which is January 2nd. Day 32, which is February 1st. You're just figuring out what day of the year the particular date is. So date 365 would be December 31st, New Year's Eve, last day of the year. Okay, 365 days in a year. Anyway, so if you can't figure the math out, let me know. I can give you the formula. However, it's pretty easy, actually. And you guys are supposed to be computer science students to some point. The initializer for the class. I talked about initializer. I'm going to be talking about initializers one more time again today when showing you some examples. Should take the parameter of an integer representing the day of the year, and the class should have a member function called print, which is going to print it out. In fact, this one's got a member function. One of these up here, the date has a print as well. Simple. That prints out the day in a month-day format. Test your class by inputting various different integers representing the days and printing out the representation of the month-day format. Okay. Demonstrate the functionality of these classes in one or more driver programs. Note, you can use the same driver program to test all 3 parts of this implementation. You do not need to create 3 separate driver programs for this. When you send me the classes, you send me the driver or drivers, depending upon how many driver programs you've created, and then the classes and the sets of the .h's and the .m's, and then you're set. I can tell very easily if it was original work as well. After looking at a first couple of them, they look very familiar after the second or third read. So I can tell. There's more than so many different ways of making these things. It's impossible for two students to turn in the same program, the same implementation. So that was number 2. Any questions on number 2 before I continue to number 3? That one's actually the hardest one, I think. It's not too bad, though. Number 3 is a cinch. Is it a cinch? It's a cinch. It's all about inheritance. Number 3. So number 2 did not require any inheritance. It was making a date class, a day of year class. You know, it was basically looking at input validation, which is kind of an interesting. And none of these have to be GUI applications either. They can be command line prompt programs. So checking the input, validating it, printing out some information about the data members that are stored in the class, stuff like that. So assignment number 3, complete all parts. Again, there's also 3 parts of it. You can put them all in one Xcode project, same as before. Put them all in one Xcode project if you want. Call it assignment number 2. Let's call this one assignment number 3 if you want. Doesn't really matter. Part 1 is about inheritance. So we have employee and production worker classes. So design a class called employee, and the class should keep the following information in the member variables. So we have data about the employee, and it should be name and a number and a hire date. Very similar to one of the assignments you had for the Java course, actually. No, not Dino. Kind of like Dino. Actually, it's very similar to Dino. None of them are as hard as Dino either, which is kind of good. Write an initializer and create the appropriate accessors and mutator functions for the class using property and synthesize, which means I don't want you to manually write them for this particular. If I say using property and synthesize, that means use these. If I don't say this, write them if you want. You know, it's optional. That is, don't create the accessors and the modifiers functions manually. Do them this way. Next, write a class called production worker that is derived from the employee class. So a production worker is an employee, and the production worker class should have member variables to hold the following information: shift, which is an integer, and the hourly pay rate, which is a double. So up here we have name and number, employee name and number, and hire date, which is basic employee information. Now we have shift. You know, you can just make up this information like shift 1, shift 2, shift 3, or something. Maybe there's like 2 shifts in a day. You can put all your people in shift 1 or shift 2. And then also the hourly rate, which is supposed to be a double, or it could be a float if you want. It's going to definitely have to have some cents to it, or 50 cents, you know, 60 cents, I don't know, half dollars. The work day is divided into 2 shifts, day and night. Okay, I forgot I put this in. So your shift can be 1 or 2, or day or night, however you want to design it. The shift variable will hold an integer representing the shift that the employee works. The day shift is shift 1, the night shift is shift 2. Write 1 or more initializers. Initializers look like constructors, if you remember from the last lecture. And the appropriate accessors and modifier functions for the class using property and synthesize. And demonstrate the classes by writing a program that uses the production worker object. This can be the same program as part 2. So it's just one driver program. In part 3, actually. Part 2, we have a shift supervisor class. And the shift, in this particular environment, we have a shift supervisor, and he's in a factory, and he's a salaried employee who survives a shift, supervises a shift. In addition to the salary, shift supervisor earns hourly bonuses when his or her shift meets production goals. So if they're doing a good job, they get a bonus. So you have to keep track of their bonus. So design a shift supervisor class that is derived from the employee class that you created in part number 1. And the shift supervisor class should have a member variable that holds the annual salary and a member variable that holds the annual production bonus. So they get a salary and a bonus that the shift supervisor has earned. Write 1 or more initializers and the appropriate accessors and modifiers, or mutators. Mutator is a modifier, essentially, for the class property, or use functions for using for class using property and synthesize. Demonstrate the class by writing a program that uses a shift supervisor object. So shift supervisor is a special kind of, well, you have to sort of see what he is. He's probably coming from employee. Because he's not, well, he could be, he's not really a production worker, he's a supervisor. So shift supervisor would be inherited from employee. Because you want to be able to reuse what you can reuse. And then we have team leader. And yeah, here he is. He's derived from employee. It's written right here. So shift supervisor comes from employee. Then we have team leader class. So in particular factory, the same factory actually. Oh, good question. You have to make that stuff up.
Okay.
It's a demo. It's an abstraction.
Should he work extra hours?
Well, it just means that his crew that he's supervising met their production goals. So you can just say, hey, we met the goals. Or no, you didn't meet the goals. It's just an item you're turning on and off, essentially selecting something to give the item in terms of, do we want to recognize it or not recognize it? Of course you have to play around with it. Create a supervisor, create a shift. I don't know. It's all an abstraction. And what I'm looking at is the implementation of the classes and the use of the classes in the driver program. So the last part of this assignment is part number 3, which is the team leader. So in a particular factory, team leader is an hourly paid and production worker. So he's an hourly paid production worker who leads a small team. In particular, in addition to the hourly pay, team leaders earn a fixed monthly bonus. So they have a monthly bonus that's associated with it. Team leaders are required to attend a minimum number of hours of training. So they have a number of hours for training as well. Design a team leader class that extends the production worker class that you designed in part number 1. Team leader class should have member variables for the monthly bonus amount. So just go ahead and create the variables for the different things, for the different parts of it. The required number of training hours and the number of training hours that the team leader has attended. So number of required training hours, number of hours that the person has attended. When it equals, they don't need any more training, essentially. So you could print out, if you wanted to, needs training, doesn't need training, depending upon how many hours they've had. Write one or more initializers and the appropriate accessors and mutators, functions using property and synthesize. So this particular assignment wants you to use property and synthesize for all of you. Your first one, second one, this is the third one. The first one, second one, I don't believe actually mentioned it. The third one is mentioning it. So go ahead and do that. Demonstrate, in fact, this is the easier method anyway. Demonstrate the class writing a program that uses a team lead object. And again, you can write the same driver program for all 3 parts. So that was actually kind of a fun assignment, I think, number 3. It's all about inheritance. So number 4, let's see. I believe number 4 and number 5 give you the choice of doing, if you want to, yeah, actually, I want to open this up in preview because it looks better. There we go. Get rid of this, make this bigger. Okay, so number 1 doesn't do anything with inheritance, just make some classes. Number 2, make some classes, multiple classes, and use them all in a driver. Number 3, used inheritance. There's some organization to this. Let's see. Number 3 is this one I just had up a few minutes ago. As a heavy-duty use of inheritance with property and synthesize. Number 4 are objects that are communicating with each other. And number 5 are objects which are communicating with each other using inheritance as well. Which is basically all you have to know for this class. So what does this mean? What do I mean by this? We have complete all parts. You can create both parts. There's only 2 parts to this, part 1 and part 2. So you have the objects that are going to be talking to each other. And what are we doing? We're simulating the concept of a parking meter and a parking ticket. So cars that or objects that are sitting waiting too long, they get a parking ticket. So how do you know if you have a parking ticket? Well, you got to look at the parking meter. Is the parking meter empty? If so, give that object a parking ticket. So based on the status of one object, you're working with another object. This is assignment number 4 and number 5 are more typical of what you get with regular old programming, especially for iPhone apps and stuff like that. Objects that are going to manipulate other objects, essentially. And there's not that much manipulation going on here. So what do we get? In fact, we don't have to worry about inheritance on this one either, actually. At least I don't think we do. Let me just see. For this assignment, you're going to design a set of classes that work together to simulate a police officer issuing a parking ticket. So the classes are working together. The other ones don't have to work together. Your shift supervisor doesn't have to give a raise to the supervisor and vice versa. That's just all demoed out any way you want to show it. So what's going on here? You have a parked car class. An object that represents a parked car. This car should simulate a parked car. What's it going to do? Nothing. It just sits there. You just make an instance. I'm parked car. Okay, good. And the class's responsibilities are to know the car's make, model, color, license. These are all the data members. Yeah. And the number of minutes that each car has been parked. And then we have the parking meter class. This is the class that simulates the parking meter. And it's responsible for to know the number of minutes of parking time that should be purchased. Just like a parking meter. And number 3, the parking ticket class. The lovely, always liked parking ticket. And that class simulates a parking ticket. So we have, in terms of the responsibility, to report the make and the model and the color of the license plate of the illegally parked car. So the parking ticket class has to go out and look to see, are there any illegally parked cars? Well, if we have a parked car that's sitting with a meter, parking meter, and that meter is empty, it needs required to be purchased, all the time needs to be purchased on it. I would say that the car is parked illegally. So if the car is parked next to a parking meter, and you're just going to have to simulate this as well, then you have to assign some logic to issue a parking ticket. So let's see what we're going to do here. So we're just going to report illegally parked cars. To report the amount of the fine as well. So it's $25 for the first hour. This is a pretty good parking simulation because in California it's like $100 or $200 somewhere. So depending upon where you're going, your ticket could be a couple $100s. So this is pretty cheap. So don't think this is realistic pricing. This is like old pricing. This is back when gas was under $1. What's the gas? Is the gas still under $5? Yeah. Okay, that's good. Okay, so yeah, it's like $4.90 something or $4.70 something. Yeah. Wow. This should probably pay more for the parking ticket than you will for a gallon of gas. Yeah, you will actually. You can't fill the whole tank though. Anyway, so it's not very cost efficient. Okay, so this is $25 for the first hour or part of an hour that a car is illegally parked. So if the car has been parked, you don't have to keep track of seconds or anything, and you can simulate this as well. You can have just 1 hour increments of your parking purchases. It's just keeping track of time any way you want to do it. You can do it in integers. Okay, so plus $10 for every additional hour or part of an hour. So if it was there for an hour and a half, then it's 1 hour for $25 for the first hour and then $10 more, so it's $35. If it's there for 2.5 hours, it's 25 plus 10 plus 10. It's only 25 for the first hour. If you make up different logic, that's fine as well. I'm seriously not going to grade you on your application of the parking fee. It's just something to use as a guideline when you create. You can actually go out, charge them 50 cents for every quarter of a second if you wanted to. I don't really care, but make it as simple as you want. This is pretty simple. To report the name and the badge number of the police officer issuing the ticket. So the police officer has to go over and look at, so if you're doing the simulation correct, you make all of these guys. And you can make them in any order you want. I'd make them in exact opposite order actually. I'd make the car, so I'll go back up this way here. Make the car, make the parking meter, and then maybe make the police officer and then make the parking ticket class. And because the police officer isn't going to issue a parking ticket object unless it needs to. So after you create the parking meter in the car, you can create the police officer. Police officer class is an object that represents a police officer. Should simulate the inspecting of the parked cars. So the class responsibilities are to know the police officer's name and badge number, because the parking ticket's going to have that information on it. So the police officer is going to have to send the information to the parking ticket class so that they can put it on the parking ticket object. So you're passing a lot of information back and forth between objects, essentially. There's no inheritance going on here. These are 4 different objects all living in a world of their own. So let's see, you want to examine the parked car object and the parking meter object and determine whether the car's time has expired. And you only have to create 1 car in this particular scenario. You don't have to create like a bunch of cars, because that would be like a lot of work. You know, create 10 cars. What? Don't have to do that. 1 car is enough. So to issue a parking ticket, you generate a parking ticket object. So you create the new object if the car's time has expired. Design it any way you want. Write a driver program that demonstrates how these classes collaborate. So the collaboration is what the point is in terms of these classes working together to get a job done. The job is issuing parking tickets to parked cars who are, you know, obviously you want to make one get a ticket, otherwise you can't. And don't make it, you know, this is a Sunday. I made the parked car and the meter's unexpirable. So, and we have no police officers that don't work on Sundays, and therefore they're not contributing, they're not creating any parking tickets. So all we have is like 1, 2 objects you have to implement, really. Now I want you to do the whole scenario. Questions about the parking ticket simulator? Okay, anyone who's gotten a parking ticket before can probably think about it. If you have not, I've gotten plenty of them. You can ask me for advice. I can tell you all about parking tickets. Part 2 is the car instrument simulator. You know when you get into a car and you have all these gauges, you know, and you're looking at the gauges like the gas gauge, and then you go to the gas tank and you put gas in the car and then the gauges change. Again, you have another bunch of objects working together. Not quite as many objects as the parking ticket simulator, but it's interesting because the odometer changes the gas level. You know, when you drive your car, you burn miles, or you burn gas, and you put on more miles on the odometer. You go to the gas station, you fill up gas, you put, you know, you get more miles left per gallon. Essentially, in the old days, that used to be how it worked. So. Alright, so this is in this assignment, in fact, you're probably going to do 2 separate programs because your parked cars and your parking tickets have nothing to do with car simulators. So you're probably going to write 2 separate drivers. If you want to put them all together, you can, but it's probably, in this case, it's probably going to be easier to write 2 separate drivers. Okay, so the car instrument simulator. We have a fuel gauge. So the fuel gauge is pretty much the, you know, the meter, essentially. The class will simulate a fuel gauge. Its responsibilities are, now we have more responsibilities. So the second one is a little bit, it's on the same level of difficulty, but it's just a little bit more. To know the car's current amount of fuel and gas in gallons, and you can make that up. Actually, I think it holds 15 gallons or something like that maximum. To report the car's current amount of fuel in gallons, to be able to increment the amount by 1 gallon, it simulates putting fuel in the car. The car can hold a maximum of 15 gallons of gas. Okay. Be able to decrement the amount of fuel in the gas, by 1 gallon. If the amount of fuel is greater than 0 gallons, this simulates burning the fuel as the car runs. Obviously, you can't burn fuel. You can't go anywhere if the car runs out of gas. We have the odometer. The odometer, this class simulates the car's odometer. So you need to know the current mileage, car's current mileage, report the car's current mileage, be able to increment the current mileage by 1 miles. The maximum mileage the odometer can store is 999,999 miles, 100,000 miles, which is actually pretty normal for regular cars. And then you go, you know, it rolls over and it starts back at 0. Which is what this one's going to do. If you simulate it long enough, it might roll over. You don't have to simulate the rollover. But when the amount is exceeded, the odometer resets itself. The mileage is now equal to 0. And then you just have to remember, oh, I put 100,000 miles on that car. Be able to work with a fuel gauge object. So the odometer works with a fuel gauge object. It should decrease the fuel gauge's object's current amount of gas by 1 gallon for every 24 miles traveled. So the fuel efficiency is only 24 miles per gallon. You can make that 45 if you want. You know, your car's a hybrid or something. It's okay. So it's actually kind of simple. There's only these two classes. So you've got the fuel. You can create any other objects that you want to work with this. But we have the pumping of the gas action, the entry of 1 gallon at a time, the burning of 1 gallon at a time, the odometer that's working with the burning, and 24 miles per gallon that's burning. And then, the odometer that increasing as the car goes on until 100,000 miles. So demonstrate the classes by creating instances of each. Simulate filling the car up with fuel and then run a loop that increments the odometer until the car runs out of fuel. So it'll be an interesting loop because you have to check the value. Probably just do a while loop. While fuel is larger than 0. Run the car. During each loop iteration, print the car's current mileage and the amount of fuel left. So it simulates what a reader is actually doing, or a odometer, like the light button, This would actually make a really cool GUI, but it doesn't have to be one. It can actually just be a command line interface with command line prompts. All of the assignments are command line utilities. Questions about assignment number 4. Last but not least, I try to make them at least interesting for you. I think that was number 4 I was on, right? Yeah. Number 5. Ships and cruise ships. Because when you get all done, you'll be thinking about vacations. Taking a vacation. So you might want to go on a cruise. We have ships, cruise ships, and cargo ship classes. What's the difference? Okay, so we have multiple lines. All of these guys are cruise ships or ships, cargo ships or ships. So we have 2 classes going from one, and we have some collaboration between the class. I don't know. Actually, you know what? Let me read through it. This one's overriding, overloading. So one of them's just pure. In fact, it's pretty easy actually. But one of them's just inheritance. The other one is collaborating classes, no inheritance. A couple of them don't have an inheritance. And then this one is just inheritance with some overriding. So design a ship class that has the following members associated with it. A member variable for the name of the ship, which is a string, excuse me. A member variable for the year the ship was built. Could be a string as well if you want. It doesn't have to be. You can actually make this anything you want. That's a recommendation. An initializer and appropriate assessors and mutators using any technique you want. So you don't actually have to you can use your freedom to do anything you want. You don't have to use property and synthesize on this. A print function that displays the ship's name and the year it was built. That's the basic ship. And then design a cruise ship. That's derived from ship class. The cruise ship class should be have the following members. A member variable for the maximum number of passengers. So this is like cars with passenger cars or trucks or different types of information. It should be an integer for the maximum number of passengers. Like this car holds 8. Excuse me, this cruise ship holds 8. This hopefully holds like 200 or something. An initializer and appropriate accessors and mutators using any technique you want. A print function that overrides the print function in the base class, so that the cruise ships class's print function should display only the name of the ship and the maximum number of passengers. So it doesn't print out the year that it was made. I think the year is in here somewhere. The year it was built. It doesn't have to print out the year, except for it's now printing out the number of passengers. Alright, so design a cargo ship that is derived from ship, and the cargo ship should have the following members, excuse me. So a member variable for the cargo capacity in tons, an integer, an initializer and appropriate assessors and mutators using any technique that you want. And lo and behold, another print function that overrides the print function in the base class, and the ship's cargo ship's print function should display only the ship's name and the ship's cargo capacity. So it's very similar to the cruise ship, the cargo ship. Demonstrate the classes in a program that has an array of ship pointers. Array of ship pointers. It has to be a pointer anyway. Well, you'll figure that out. The array elements should be initialized with the addresses of the dynamically allocated ship, cruise ship, and cargo ship objects. The program should then step through the array, calling each object's print function. That sounds a lot harder than it really is. It's actually fairly easy. In fact, this is probably really easy compared to the other ones. This is just practicing overwriting. And that's actually the last of the 5 assignments. You have to do the worth 10 points each, or 50% of the grade in the course. The other 25% of your grade I also posted up this weekend, and it is the CSLO essay. And I forgot to download it, so I'll download it right now. It's right here, CSLO essay assignment. Let's see. I will put it on my desktop. It is worth 25% as well as the final exam, which is also another 25%. Let's see, let me open this up in preview. What do you have to do for this? Same as before. Same as the other ones you've written for my classes. You get to pick a topic. And again, make sure your topic doesn't match, well, excuse me, make sure your essay doesn't match somebody else's essay. That's an issue. You must write the essay yourself. You have a lot of freedom, however, in the topic selection that you pick. The first one, in fact, there's a little bit of overlap, which is why I'm sort of bringing this up. And if you're also in the iPhone class, I highly encourage you to actually pick 2 separate topics, because you could probably, and don't recycle the essays between the 2. So if you're in the iPhone class, turn in a separate CSLO for that class. Can't be the same CSLO you're turning in for the Objective-C class. Because of the overlap in some of these topic areas, I can easily see a student trying to turn in one for both. You only get credit on it once. If it matches your own, you won't get, you'll get credit, but it only counts for one time. It doesn't count twice. In fact, I'd have to mention that one as well, because I know some students are going to try and do that. Okay, so pick a topic, any topic. No, just one topic. Actually, you can pick number 7, which is select any topic you want. So, select one of these, write a 2 to 3 page. I've never had any problems with page lengths. Page lengths have always been good. The only problem I usually have is cutting and pasting off of the internet. Try not to avoid cutting and pasting from Wikipedia. Because if everybody cuts and pastes from Wikipedia and more than 50% of it matches, it's considered plagiarism, actually. So you won't get any credit for it. Even if you wrote it yourself, but you cut and pasted it off the internet, you still don't get any credit for it. Alright, I've seen everything. So let's see, topic number 1. Describe the basic concepts and techniques of developing applications for the Mac OS X. When you answer that question, please focus on Objective-C or COCA interface, or both, actually. What makes Objective-C different as a language, and why is it used for development of the Mac OS X platform? I don't know if you can really, personally, I don't know if you could really answer 2 to 3 pages for that question, so you might have to change it slightly to make sure you can get the page length correct. So this probably, I can probably answer this in a paragraph or so. But you want to write 2 to 3 pages double-spaced. So, which is what, 1.5 pages, single space, 1 to 1.5 pages. So you might have to ad-lib a little bit. You might want to do both questions together. You can do that as well. You don't have to tell me which question you answered. You can just, or you can tell me number 7. Select a topic of your choice that relates to object-oriented programming and Objective-C and write an essay on that topic. Which is kind of like combining 2 of these. These are some topic suggestions, or what these are. Number 2. What is COCA and how is it used with Objective-C and Mac OS X developments? Describe the libraries and interfaces and how they are used. This is all about COCA question. Actually, believe it or not, in the Java programming course, I had people giving me Java EE CSLOs as well, and you didn't get any credit for it if it was a, if I had caught it fast enough, you didn't get any credit for it if it was an EE one either, because that was from the Java EE class, so don't recycle from any other class you've taken. Let's see, describe the interface builder and how it's used in application development for the GUI applications. Compare the features in the interface builder with other IDE tools. So that's all about the interface builder. You can compare the interface builder with Swing as an example. You could take the interface builder for the iPhone and compare it with XML interface, menus and stuff that you create with the Android if you wanted to. That actually might make for an interesting essay, actually. Actually, number 4 would probably make for a good essay as well, because the Objective-C language is so similar to Smalltalk and C. In fact, they're an extension of both languages, but they're not very similar to, it's not very similar to Java or C++. So you can do a compare and contrast of all of these different languages. That might actually be an interesting essay as well. So. Number 5, describe the concepts of object-oriented programming and design as they are implemented in the Objective-C language. Well, object-oriented programming and design is something that's going to be really nice to compare because Objective-C is a purely object-oriented language. So that would make for an interesting object-oriented design and object-oriented programming methodology kind of discussion. So that would be a good one too. Number 6 would actually be an excellent one as well, given, if you know anything about or have an interest in researching the Model View Controller, MVC. What is MVC? Describe the design pattern and how it's used. It is a design pattern, by the way, used in more than just Objective-C. It's used in a couple of other things, languages and platforms on the market. How it's used to build Objective-C applications for the Mac OS X and the iOS platform. And then, lucky number 7, you don't like any of these, pick one of your own. It has to be on Objective-C, however, don't give me a Java EE CSLO essay. It has to be on Objective-C programming. Questions about the CSLO essay. All of this stuff, as before, is entered into the EMS, and it is all due on August 27th, which is the very last day of the class, which is the day of the final exam. Don't wait until the week before and tell me, oh, it didn't get uploaded correctly. I can't do anything for you. You're in luck if you just upload them while you're doing the assignments, because then you'll be able to make sure that it actually gets uploaded correctly, stuff like that. So, do we have any questions on any of the 5 assignments or the CSLOs? And the other thing you have for this course is the final exam, obviously, which is going to be in class, the last day of class. Okay, so I'm going to end this one then.